All right, guys, in this video, we're going to be looking at some properties of equilibrium constants. And what that means is we're going to change the reaction. We're either going to flip it or double the amounts, and we're going to see how that changes the equilibrium constant. Before we get started, let's just talk about those changes. So let's say K equals 10. Well, if we were, let's say we have A goes to make B, and that's equilibrium. If I were to flip it, B to A, now the K gets, we put 1 over the K, so it would be 1 over 10. So this equilibrium constant would be 0.1. That would be the change if we did it that way. Let's say I then made a change and it becomes 2A and 2B. So I'm doubling that. Then the K value will change because I will then square it since it's being doubled. So K will equal 100. All right, those are the changes that we'll see in these questions that we do. So here we've got a reaction here at the top, and the value of that equilibrium constant for the reaction represented above is 2.3 times 10 to the 11th. 2.3 times 10 to the 11th. What is the value of the equilibrium constant for the following reaction? So the difference between these two reactions is they are going to flip it. Here the reactants are Ge and Cl2, and here it becomes the products, and this product becomes the reactant. So because they flip, we are also going to have to take our K value and put it over 1. Okay, something we also have to do is notice that the values get doubled. Here we have a 1, 2, 1, and then it becomes 2, 2, 4. So it gets doubled, so whatever I get there will be then squared. So ultimately, I'm going to take my K value, plug that in, so I'll get 1 over 2.3 times 10 to the 11th, and then I will square that answer to get my final answer. You can do that in your calculator. You're going to plug it in. You're going to find that we get A as our answer, 1.9 times 10 to the negative 23rd power. And that's it. That's all you got to do. So as long as you know the K value of one reaction, however you manipulate that reaction, you can change that K value to get to the answer that you're looking for. So the new equilibrium constant for the different reaction. Okay, this question is a multiple or a short answer. We're given this data table of reactants and products, and there's time 0 to time 8, and the pressures are changing, so it's going through some sort of reaction. The first thing it wants us to do, determine the value of the equilibrium constant Kp for the reaction represented below. Okay, so here's my reaction, here's my data table. So first I want to make my Kp expression. Okay, Kp for this one is going to be my pressure of my products, HBr on bottom, or on top, sorry, and that's squared. And that's going to be over my reactants, the pressure of the H2 times the pressure of the Br2. Okay. Now I got to figure out the values. Well, on my data table, I got to find where is it equilibrium. Here is the start of my reaction, and as I see as I go down, my reaction is still going all the way till time 7. At time 7, I have equilibrium. So I can use these values to plug into my values down here to actually solve for my Kp. So at equilibrium, my pressure of my HBr, which is this far right column, is 1.2, and that has to get squared. And my other two pressures will be 0.4 of each of those. So if I plug that into my calculator, let me pull my calculator out, I go 1.2 squared. And then I'm going to divide that by 0.4 times 0.4. I get 9. So right here, my Kp equals 9. Nice big box so the grader can see it, and they can see my work. Boom, full points for that question. Now G is continuation of that. Part G, I should say. Using the value determined in part F, which was 9, determine the value of the Kp prime. They like to put prime for differentiating between the original Kp and the new Kp for the equation below. So we started with this reaction, we ended with this reaction. They have changed these reactions, but it's the same type of reaction, they've just changed it. and we have to know the new Kp prime. Now, all they did was double the amount. They didn't flip it. I can still see my hydrogen bromine are my reactants, and my HBr is my product. So all they have done is double it. So my Kp prime is just going to be Kp squared. So my Kp prime is equal to 9 squared, which is 81. So my Kp prime is just 81. And that is my answer for that one. Hopefully that was helpful in kind of seeing how we can manipulate the equilibrium constant if the reaction changes, whether it's doubled or flipped in that aspect. And those are probably the main ones you'll see on the AP test.